Hello everyone. Today we will discuss the basic requirements for sponge city planning. The main entity responsible for sponge cities is the municipal government. The municipal government coordinates the planning, land management, drainage, roads, transportation, landscaping, and hydrology departments. In relevant planning processes, the construction of low-impact development LID rainwater systems should be implemented. Sponge city planning should align with urban and rural planning systems and can be divided into general planning and detailed planning levels. To meet short-term construction needs, the goals and strategies of sponge city planning can be further refined through implementation plans. Sponge city planning must also align with urban and rural planning at the same level and maintain consistent scope. Sponge city planning is generally divided into 3 levels. The first is the general planning level. The second is the detailed planning level. The third is the project implementation plan level. First, let's discuss the general planning level. The general planning level should outline the basic requirements for sponge city development and incorporate sponge city concepts into key control indicators and spatial management elements. Innovative planning concepts and methods should treat LID stormwater systems as key tools for new urbanization and ecological civilization development. Specialized studies on LID should address ecological protection, land use, water systems, green spaces, infrastructure, and environmental protection. These studies should determine city-specific annual runoff control rates and design rainfall targets, establish strategies and priorities for LID stormwater systems, and integrate these into urban water system drainage, green space, and transportation plans. Detailed planning includes regulatory and construction level detailed plans. It should implement the sponge city control targets and indicators set in the general and special plans, and adapt LID facilities for stormwater infiltration, retention, storage, purification, utilization, and discharge. Control indicators such as per unit area runoff volume, sunken green area ratio, depth, permeable pavement ratio, and green roof ratio should be specified to guide lower-tier planning or land transfer and development. Cities or new districts with suitable conditions can develop LID-based stormwater management plans, balancing total runoff, peak runoff, pollution control, and resource utilization to establish comprehensive stormwater control systems from source to end. Digital modeling and other methods can analyze and break down LID control indicators. Refining design guidelines for reference in urban and professional planning. This includes implementing LID stormwater system construction, scheduling, funding, and safeguarding. As part of the general city plan, it can also explore integrating LID systems into the urban water system. Eco-cities and green buildings as key components of the National Green Urbanization Strategy significantly impact urban development and living environment improvement in the long term. LID control targets should be incorporated into evaluation standards for eco-cities and green buildings through indicators like runoff volume control, sunken green ratio and depth, permeable pavement ratio, and green roof ratio. The detailed planning level of sponge city planning should include the following. First, analyze the factors affecting sponge city development, including regional hydrogeology, drainage systems, surface characteristics, and functional zoning. Second, from higher-level plans, implement the sponge city control targets and construction requirements by delineating control units within secondary management zones. Use land parcels as basic units To break down and apply control indicators and other planning requirements. Third, develop a systematic plan for sponge city construction. By specifying requirements and key measures for various land uses. And arranging public sponge facilities appropriately. Fourth, prepare sponge city planning diagrams that include control indicators and planning guidelines for each land parcel. Fifth, address areas with severe runoff pollution, such as industrial zones, particularly those converted from industrial to residential land. The indicators proposed in detailed sponge city planning should include control indicators and guiding indicators. Control indicators are binding or mandatory metrics designed to meet control targets or construction requirements. Generally, they include runoff reduction per parcel based on annual runoff control targets, based on zone targets and parcel conditions. Additional indicators such as runoff pollution control and peak runoff reduction should be devised to establish a parcel-level control system. Guiding indicators are advisory metrics for achieving control targets or construction needs. They help achieve additional sponge city goals outside of the control indicators or guide the implementation of control indicators. The third level is the project implementation plan. The implementation plan is primarily based on the scope of detailed sponge city planning, but can also focus on specific land parcels, neighborhoods, or catchment areas with special needs. The primary goal of the implementation plan is to apply detailed planning-level sponge city control indicators and systematically guide construction across land parcels. A sponge city project implementation plan should include the following. First, based on higher-level control indicators, comprehensively analyze surface characteristics, municipal drainage, green spaces, water systems, development goals, architectural controls, and landscape requirements to propose main goals and measures for sponge city construction, while identifying potential conflicts and challenges. Second, clarify construction goals and measures, while referencing guiding indicators from higher-level plans, and analyzing sponge facility characteristics to create facility selection schemes. Third, develop facility layout plans, design facility parameters, and complete scenario plans for sponge city planning. Fourth, using rainfall runoff models and decision support systems to evaluate and validate runoff control effects of planning scenarios. Fifth, considering facility performance, operation and maintenance costs, ecological benefits, and other factors, by using modeling software or mathematical methods. Optimize the initial planning scenario to form a scientific, feasible, and cost-effective implementation plan. These are the basic requirements for sponge city planning.